So, hi guys, I congrats Kalush Orchestra winning of the Eurovision. So, guys, you are amazing, and yeah, for sure, the Mariupol and Azovstal is a huge uh, sadness of Ukrainian nation right now. So, please support them as far as you can. But today we will talk about some interesting things about the modeling and actually the development experience. And when we talking about development experience, people immediately start talking about the DevOps, pipelines, all of the things. They all important, but for me, the most important part of the development experience actually is the cognitive load. Yeah, so developers always have the cognitive load to understand the system, to understand the code. Actually, I was talking a lot on Ukrainian language, how we could use the code as a database, how to visualize the code and all of the things. But the biggest problem of all the times that we have the huge gap between the architecture and the code. So you open any kind of architecture diagrams and you see something that you will never find in a code. So, and even in an architecture level, you have the solution architect and you have the application architect, and you could read interesting books like the architecture elevator that will describe how these two guys should work together, but still we have the huge mental gap that create a huge cognitive load for the people. And how we are going to survive and how we surviving on Affinity. So today we will talk about the models, what kind of models for the architecture we use. And first thing that you should understand that all models are wrong, some models are useful. And yeah, the architecture itself is just a set of useful models that help you to take the decisions, technical decisions or product decisions on your architecture. So how to eliminate this gap between the architecture and code? We actually use the C4. I will propose you even not C4 but C5 diagramming approach. So we have the set of quite simple diagrams. We use the special plugins for Plant UML, so our diagrams actually is the code that you just have the text DSL that help you write it faster, keep it in your repo and have the versions and ask other people to review. If you are lucky and use GitLab, you will have even the visualization of all your diagrams out of the box. You don't need to render them, so it will be visible in Markdown. But what's C4 or C5 is about? So it's simple, quite simple, 4 or sometimes 5, yeah, diagrams that allows you layer by, not even layer by layer, but it's allow you to build your system architecture from the different scales. So the first diagram and most important diagram, it's the context diagram or the system diagram, when you just put your system in the middle and describe all other third-party systems or customers or users and their relations to your system. So you give the broad context, who used this piece of software and why. And it's the most important thing, and it should be understandable to do your products and your customers, and they should find themselves on this diagram. So after that, we have the next level, and this level is containers. And containers, it's self-descriptive, self-deployable modules. So you take your system and decompose to these containers and keep the relations between these containers. And what's more important, if you, for example, use Kafka, don't put Kafka in the middle and connect all containers to the Kafka. It doesn't make sense. I will explain later how we could describe this, but try to have the meaningful relations, why these containers interact with each other, and how this containers actually use each other, so it's more important than all other things. And after container diagram, that this self-deployable modules, it could be, for example, mobile app, web app, some services connected together, or maybe even family of the services that create some bigger module. Yeah, be creative there. After the containers, we grab every container, and on every container we have the components. And components, actually, it could be some fine-grained pieces. Yeah, it could be some parts or subsystems of your services, or it could be something like databases or storages or whatever. But this component is most flexible thing. And in theory, every container should be broken to the components. So you go from system to containers, from containers to components, so your diagram is growing and growing. And in some products it's even possible to click through all this and go deeper. Yeah, so it's really cool, I like it. The last part actually is classes, but I never do this. I'm not a big fan of the UML itself, and it's quite rarely that you really need to go to the classes. But what's useful when you go to containers back, why it's a C5? Because we have yet another diagram that complement the containers. It's connections, and here we have not just a logical who use whom, but we grab our containers and we focus on this diagram on real connections between them. So if they use the message queue, then put the message queue there. If we use Kafka, put Kafka. And really focus not on the boxes and logical connection, but the boxes and real connection that they have. So it will be quite helpful when you have a lot of infrastructure tricks and message brokers and all other things, because you could put all these details there. So, and as a result, you have human readable, quite well designed diagrams that simple to read, because people do not need to learn some special language for this. And you have quite cool tooling. I will leave some links in a video. So the coolest part is the C4 plant UML. So you have text DSL that allows you to build it quickly. Structurizer, it's another thing that have the next level of the DSL. Yeah, that you describe not the plant UML blocks, but you describe already in terms of all these containers, systems, contexts, and so on. So it's more domain-specific language of describing your C4 level diagrams, and it's quite useful, but you need to pay for products, but DSL itself is free, so why not? You could try to use it. We happy with the plant UML. But what we get, that we have this self-expanding thing from systems to containers to components with connections, and then to some really deep things that could be connected to the code. And it's already, it's already give your developers possibility to understand the system better, lower the entry to the code base, and actually just lower the cognitive load that people have, because people understand it from high level and down and down and down. So it's extremely useful, even if majority of our models is broken, and we're still looking for a language that really could transform your high architecture concepts to the code. Yeah, and I will talk about some languages that was invented before I was born, that actually have the lowest cognitive load that we ever have, but we all forget about them. But it will be in my next video. So please subscribe to our channel, write some comments, give some feedback, how you model, how you solve this problem of the impedance and the knowledge transfer to between the products, architects and developers. It's really eating my brain. And stand with Ukraine and support Ukraine, and see you. Bye.